Starting off page number 2 here, you are basically got to graph these guys. We've done so much of this practice in class. If you want to make a table of these guys, that's an awesome way of doing it. You're trying to find these other things, roots, zeros, vertical intercept, lots of stuff to do. Let's just tackle it step by step. So letter A, finding the roots and zeros. That means to set the entire equation equal to 0. When you've done this, we can use what is called the zero product property. The zero product property says that if two things are being multiplied together and end up being 0, one of them must be 0. Again, we've done this before. X plus 3 equals 0, x minus 5 equals 0, x equals negative 3, and x equals 5. Now, again, if you can just look right at this and say, oh yeah, it's definitely negative 3. If I plug that in, I'll get 0. Oh, it's definitely 5. I plug that in, I get 0. Good for you. Do that. So we get these two guys are our zeros. So we have zeros right here. Letter B, determine that axis of symmetry. Axis of symmetry is always smack dab in between those two zeros. So B here, we got negative 3 plus 5, all of that divided by 2. That's going to be 2 divided by 2, and that's going to be 1. So x equals 1 is going to be our axis of symmetry. Looks like our A's, B's, and C's got kind of all messed up, so I'm going to go ahead and say that this is our letter C here, and this is our letter D here. Yeah, basically C, vertical intercept there. Vertical intercept is always so easy. You just got to plug in 0 into this thing. That is to say, plug in 0 into this, and that's going to give you 0 plus 3 multiplied by 0 minus 5, and you will get the coordinate 0, comma, negative 15. 3 times negative 5. Super simple vertical intercept there. D, determine the coordinates of the vertex. To determine the coordinates of the vertex, we're going to use our axis of symmetry value and plug her into the function. So we got f of 1, and that's going to be 1 plus 3 multiplied by 1 minus 5, and that's going to give us 4 multiplied by negative 4, and that's going to give us negative 16 for a final coordinate of 1, comma, negative 16. Accurate, neatly draw the graph of the function. Be sure to include 5 points on the graph. So let's just go ahead and put the points down that we already have. We have this 1 comma negative 16. We know that's the vertex of the function. We know it's the bottom or the top of our function. In this case, it's a positive happy face one, so it's going to be the bottom. So we got 1, negative 16, but if I count my dots, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have 16. So because of that, I'm going to have to go ahead and count by 2's. So every single one of these is going to be a 2, so I'm going to go ahead and mark a little 2 there for myself to let myself know that those are all going to be 2 and actually negative, right, because it's going down. So we got 1, comma, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16. Boom, right there. Then it says 0, comma, negative 15 is our next coordinate. So let's go ahead and put that guy right there. Don't forget we're going by 2's, so it's got to be halfway in between those guys. Continuing on, we have to make sure we have this negative 3 and 5 on there. Remember, that means they're zeros. That is to say they are x-intercepts. 1, 2, 3, negative, easy. 1, 2, 3, 4, 5, easy enough. You need 5 coordinates. Remember, axis of symmetry is this x equals 1. It goes right through the vertex, so it must be the same on both sides. So this coordinate right there must also be nice and neat. Just to make my graph neater, I'm going to go ahead and figure out some of these other values over here. You don't really have to do this, but I do think it makes the graph a little bit prettier if you just plug in some other values. So if you did decide to, you could plug in 3, for instance, into the function. If you do that work, you will end up getting, 3 plus 3 is 6, 3 minus 5 is negative 2, and 6 multiplied by negative 2 is negative 12, so you got 3 comma negative 12. I'm also going to plug in 4, see what I get. If I plug in 4, that's going to be 7 multiplied by negative 1. That's going to be the coordinate 4 comma negative 7. These shouldn't be equal signs. These should be arrows. 4 comma negative 7. So, yeah, let's do it. 3, 1, 2, 3, and it's negative 12. These go by 2's, don't forget. So, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. And plugging in 4 gives you -7, so -2, -4, -6, -7's right there. And we have to have exactly the same ones on the other side. So we're going to have this guy right here and this guy right here. Beautiful. Easy enough. Going to do exactly the same process for all of these. I'm just going to choose to only do 2 of these problems just because it is kind of tedious just to go through all of them in one sitting. So I'm just going to go ahead and just do number 3 only. You can do these ones on your own time here. So -5x squared minus 11x minus 6. First things first, I'm going to try to factor this. So f of x is going to be negative 5x squared plus 11x plus 6. After that, this is one of the tougher factoring questions. We're going to have to multiply the edges here. 5 times 6. 5 times 6 on the outside here is going to be 30. And then you have to figure out what multiplies to 30 and adds to 11. Luckily for us, we've already done that. 5 and 6 work out nice and neat. Oh boy. So that 11x is going to become a 5 and a 6. So negative 5x squared plus 5x plus 6x plus 6. Draw a little squiggly line down the middle. And therefore you'll get negative 5x pulled out from these two on the left-hand side of the squiggly. When you do that, you'll get x plus 1. After that, the right-hand side of the squiggly, you can pull out a 6, x plus 1 again. Finalizing this up, we got negative, big parentheses. X plus 1 is in both of them, so we can factor out an x plus 1. What's left over is a 5x plus 6. The whole point of doing this is to find the roots and zeros. Because we're trying to find those roots and zeros, we're setting this entire thing equal to 0. In other words, we know that x plus 1 must equal 0, so x equals -1. Or 5x plus 6 equals 0. That's going to give you 5x equals -6, and therefore x equals -6 over 5. In your calculator, that is a -1.2. Because this graph is going to have a -1, 0 and a -1.2, 0, I definitely don't want my tick marks to go by 1s here. That's going to be a little bit obnoxious for sure. In fact, I'm going to make the tick marks all go by 0.1. So we're going to go ahead and say, this goes by a 0.1, a 0.2, so on and so forth. So I'm going to go ahead and mark that on there. Those go by 0.1s. And we know that we are going all the way out to -1.2. Actually, that's going to be off the page, isn't it? That's not going to work. We'll have to go by 0.2s instead. Oh well, there you go. So we got -0.2, -0.4, -0.6, -0.8, -1. There's that -1, 0, and -1.2, 0. Those are right next to each other. This graph's going to look funky. I'm going to be honest. Definitely a weird one. Right in between -1 and -1.2, this was the letter A. The letter B here. What do we have to do? We're finding the axis of symmetry. We've got to add those two together. -1 plus -1.2. Divide by 0. Oh my gosh, guys. I cannot believe I just wrote that on here. You're dividing by 2. You're finding the average of two things. What nonsense I've just written. You do this, you get -2.2 divided by 2, which is -1.1. So -1.1 is our axis of symmetry. So the axis of symmetry goes smack dab in between these guys right here. So in order to do the next part of these, you're going to find the vertical intercept, plug in 0. Very, very easy when it's in standard form, by the way. 0, -0, -6. So letter C here, we have plugging in 0, and we get -6. So plugging in 0, we get 1, 2, 3, 4, 5, 6. Don't forget, we actually know another coordinate right away because of that. It has to be the same on both sides of the axis of symmetry. So we have 1, 2, 3, 4, 5 and a half tick marks. So half, 1, 2, 3, 4, 5. This coordinate right there has to be on the graph as well. So the vertex definitely got to be right here somewhere. You actually got to plug that in, though, to figure that out. We have to do f of negative 1.1. And, yeah, that's not really part of my game plan to do that by hand. So that's going to be calculator time. So taking our calculator out. There is a fast way to do this. I'm going to switch over to right here so it's right in the light. So turn your calculator on. You want to go to y equals. Once you go to y equals, you want to go ahead and type in the entire thing, the entire f of x right here. So we're going to type it in just as it appears. We're going to do negative 5x squared minus 11x minus 6. Be very careful. If you noticed, I used different negative signs in this question. I used the small negative sign here on top of this negative 5. That's this sign, right? That's that negative sign right there. That makes a number negative. But these two, I actually used the big negative sign. I subtracted them. Make sure you use the right buttons. Anyways, once you've done that, you can hit the graph button. A little graph shows up. Hopefully it has some of the same coordinates we're doing. Remember that we're doing, ours looks a little bit different on my graph because I'm going by point ones. I can show you how to go to point ones in the calculator in just a moment. So, yeah, we need to plug in negative 1.1. So we hit trace, and you type in negative 1.1. You hit enter, and it looks like 0.05 is the correct answer. So 0.05. That guy right there. So we have the coordinate negative 1.1. Oh, boy. Negative 1.1 comma 0.05. And that's going to be barely above this, and you know what? Honestly, that's 5 coordinates. That's good enough for my graph. I'm satisfied. If you're having more issues with this and you want more coordinates on there, you want your graph to look like this, you're gonna have to, on the calculator, you're gonna have to do a little bit of a switcheroos here. Gotta do some smart moves. So the smart move here is to hit the window button. My x minimum all the way over here, the farthest left-hand value. Looks like it's actually going to be negative 2 all the way on the left-hand side there. The way I figured that out is I'm going by 0.2s, and I got 10 of them. So that means the maximum is also 2 all the way on the right-hand side. And my y scale, I did make that go by 1, so we'll just leave it like this. See if it shows up just like my picture does now. Let's see. Nice. Definitely does show up just the same, or, you know, my version of the same. Looks nice and pretty. If you're having more issues and you still don't like this calculator, another way you can deal with this is to get the table going. Now, if you hit the table button, which I did by hitting second table, you get some weird numbers all the way. It looks like they tried to plug in 70 and 130 and all these other numbers. It might be a little bit easier instead if your table went up by the same values as your x did. They're all going by 0.2s, or maybe even 0.1, so you can get that vertex right there. So let's go ahead and hit second window to get the table setting. We want our window, we want our very first value to be the far left-hand number, so we want this to start at negative 2. And I was saying maybe go up by those 0.1s so they can always increase and actually see that vertex. Hit second table. And nice and neat, we get all these coordinates. If you wanted to make your graph super beautiful, you could graph all of these. And that negative 1, the negative 1.2 are those zeros that we found. Negative 1.1, comma 0.05, there's our vertex. And if we scroll all the way down to 0 even, we get that negative 6 that we had. Anyways, there's that graph. Hopefully this was helpful to you. I'm going on to the next page in the next video.